Hey kids, welcome to another math lesson. This is for Eureka Math, grade 5, module 3, lesson 4, homework. And go watch the problem set video first. That is my recommendation to you so that you know what you're doing, you know what fractions look like when they are greater than 1, because that's what our fractions may look like today. So if you check out the objective at the bottom of the page, add fractions with sums between 1 and 2. Well, it's nice when they tell you what the answer is supposed to be. In case you don't get the right answer, you can go back and look and see, hey, something went wrong. So the directions for the following problems: draw a picture using the rectangular fraction model and write the answer. When possible, write your answer as a mixed number. You should know what a mixed number is by now. If you don't, go watch the problem set video. Okay, so we're going to just jump right in because you should know how to do this, because we did it in previous videos and you already watched the problem set, or you just did that with your teacher and you kind of know what you're doing and you already did your homework, and so you're just checking, which is as it should be. So here we have fourths and we have 3 of them shaded. Here we have thirds and we have 1 shaded. And yes, it matters that you have these vertical and these horizontal. If you don't have it like that, go fix it. Like, that's the way it should be. Okay, and then you take your thirds and you cross over this way, and you take your fourths and you stripe down this way. And now we have equivalent fractions, and we have twelfths in each. And with our twelfths, the number of shaded pieces are now changed because of the striping that we just did. I talked in my previous video about cross multiplying, taking that denominator. When I'm making thirds out of fourths, I will get twelfths, but I also have to consider that my numerator will change 3 times as many. So here we have 9. You should have 9 on top, and then for this one you should have 4 that are shaded here. Now notice that 9 plus 4 gives you 13. Twelfths is our label, and so this is really a division problem. Remember that improper fractions are simply a division problem. Top divided by bottom. How many 12s can you fit into 13? 1. Okay, when you do all your steps, what do you have left over? The 1, or the remainder, is going to be how many pieces are left over out of 12ths, which is our label. And so I have 1 left over out of 12. So if I took all 4 of these and I went, okay, I'll put 1 here, 1 here, 1 here, I would have 1 whole shaded in with 1 out of 12 left over. So that's what we're doing here, and I hope you can see that. And you don't have to do this part, but this should help you see what you're doing when you do this division here and how you have 1 left over. Let's do another one. Or check another one. 3/4 again. Plus 2/3. This one, 2/3. Okay, so fourths and thirds again. Come on, give us something new. Give us something interesting. So I have 12ths. Got to lay my pieces over the top so I can have my visual model that matches. Ay, ay, ay. Messy. Messy. Oh, and if a fly comes and dive bombs me today again, there was one in here, so just be on the lookout. Anyway, so here we have our 3 times 3 is 9. You can count, of course, if you want. 4 times 2 is 8. Again, you can count, but you're just making these equivalent models. 17 is your sum as you go across. 12ths is your label. And here, again, we have an improper fraction. So using this without doing the long division, how many 12s can you fit into 17? That's 1 time. Then the difference between these two is your new numerator. So 1 and 5/12 is your answer for B. Move it up and make it blurry just for fun. Focus. Okay. 1/3 shaded plus 3/5. 1, 2, 3, 4, 5. 3 of them are shaded. Make your equivalents. Fifths here, thirds here. Okay, don't do any additional shading. 3 times 5 will give you 15. And then if you cross multiply or look, if I make fifths out of thirds, then I have, if it was formerly 1 shaded, it's 1 times 5 and 3 times 3. Add those together. And on this one, I have a proper fraction with a smaller piece on the top than on the bottom. So I do not have an improper fraction. Therefore, I don't have to have a mixed number. I can move on. And sixths, I'm going to divide in half. Then I'll do thirds on the left and thirds on the right. And 5 of them should be shaded. So it's really the whole thing except for 1. Plus 1/2. Thank goodness. That's easy. Again, remember, vertical, horizontal. First one vertical, second one horizontal. Lay your pieces over, halves, that's easy. But now sixths, half, then thirds on the left and thirds on the right. That way it gives you 6. Okay, the total number of pieces now is 12 because it's 6 times 2. Creating 12ths on the bottom. How many are shaded on the left side? 10. How many are shaded on the right side? 6. Add those together. You get 16 twelfths. So what's the difference between here? Because that's going to be your numerator. I can fit 1. It's like 12 twelfths. That makes 1. That's where we get that. And then the difference between these two. Now, they didn't say to simplify here, so you could leave it at 1 and 4 twelfths. But previous video, I was saying, hey, you can divide by 2. Yes, you can, because they're both even numbers. But if there's a bigger number that you can divide by, you should divide by it. So the greatest common factor of these two, that's going to give you the simplest form answer as quickly as possible. Don't forget your 1. Copy that over. 4 divided by 4 is 1, and 12 divided by 4 is 3. Now, if I did this, I'd have to have 2 steps because I would get 2 and 6, and then I would have to divide by 2 again. That's where you go, oops, I didn't do it the best way the first time. And then you can eventually get to the 1/3, and don't forget your 1 that would go with that. So anyway, 1 and 4 twelfths is equal to 1 and 1/3. They have the same value. This one is simplified. This one is not. Okay, on the back. 2/3. Vertical. Shade the left if you like, or shade the right, but only 2. 5/6. Okay, cut it in half, then put 2 lines to make 3 spaces on the top, same on the bottom. Now you have to shade 5 of them. Be careful, shade everything all the way up and leave 1 at the bottom. Make your equivalents by making sixths here and thirds here. Hopefully you already did all this. Now, how many pieces do you have? Well, 3 times 6 is 18, so we've made 18ths out of these fractions. How many are shaded here? The sixths that were laid over the thirds would have the 2 sets of 6 for 12, 2 times 6, and then 3 sets of 5 or 5 sets of 3 for 15. Now we're going to add those together and get 27 18ths. So now here you've got basically your 18 18ths is equal to the 1, okay? And then the difference between 27 and 18. Now, I've got another could be simplified. Remember, to find the greatest common factor that would go into both of these is 9. Divide both the top and the bottom. Don't forget your 1. This 1 and 9 18ths is equal to 1 and 1/2. Oops, half. And I have a special video. I think I made it last year, and it was on Mrs. Setness's rules for simplifying fractions. Go watch that if you want to have 3 simple ways to simplify fractions. I think it kind of narrows it down for 5th graders pretty well. Anyway, 1.5 is your final answer there. And then if you look, we're starting with a fraction greater than 1. So we already know we're going to have an answer greater than 1. So 4/3 requires 2 boxes. So hopefully you got this part right. But it's thirds. Remember, your label is thirds. That means how many pieces in 1. But they're telling you to shade 4 of them. So it's the entire whole first one and 1 here, because it's 3/3 plus 1/3. That makes 4/3. Okay, that's where you get that. That's what it means. Now to this number, we're going to add 4/7. And we have to, I can't cut it in half. So 1, 2, 3, 4, 5, 6, 7. And 4 are shaded. 1, 2, 3, 4. Okay, so 3 are not shaded. Count correctly. 4 are shaded, 3 are not. Now we have to lay over our fraction models just like we did before. So 7, 1, 2, 3, 4, 5, 6, 7. Also here. 1, 2, 3, 4, 5, 6, 7. And this one is a lot easier. Just make thirds. So how many pieces did we make in each one? Well, we made 21 pieces in each because 7 times 3 is 21. So how many pieces are shaded here? Well, if 21 21s or 21 21sts would be the whole thing, I've actually got more than that because remember, you have more than 1. So go ahead and do that cross multiplication to get your 28 for the first number and then 12 for the second number. 4 sets of 3 or 3 sets of 4. Either way, it's 3 times 4. Now we combine those, and 28 and 12 make 40. And now we have an improper fraction that we have to kind of straighten out. So again, 21 21sts would be 1. So it's the leftovers between 21 and 40 that would make our numerator. So 1, and how many are left over? 19 21sts. Okay, you can always set it up and do long division. Right here, 40 divided by 21, or you can do 40 minus 21 if all you need is the numerator. Okay, only a couple more. Hang in there. Solve the following problems. Draw a picture and write the number sentence that proves the answer. Simplify your answer if possible. They said on the first one you don't have to do it, or they didn't specifically say you did, so you could have left it, but now we really need to watch out for the simplifying. Sam made 2/3 liter of punch and 3/4 liter of tea to take to a party. How many liters of beverages did Sam bring to the party? Notice it's all the same. Thank goodness we don't have any conversions while we're learning how to add fractions. So we're going to combine the punch and the tea because those are both different types of beverages. Beverages, fancy word for something you drink. 2/3 plus 3/4. You can make your model here below. Shade 2. Make your model. Shade 3. Cross over or lay over the other fraction pieces to find your equivalent. See how many pieces there are in total, or multiply your 2 bottom numbers, the denominators, to get 12ths. This is where the cross multiplying, 4ths on top of thirds would make 12ths, but 4 on top of 2 is going to make 8 that are shaded. And 3 times 3 is 9, same thing. 3 sections were shaded and then divided in thirds. 8 plus 9. I feel like we did this already and got 17/12. And you could go check back on the previous page and get your 1 5/12 liters of beverages he will take. Sam will take, will bring. I'm just writing the words from the question. Always go back if it's a word problem, figure out what it is that the answer is talking about and label correctly. Okay. Click subscribe, come back again, and we'll do some more math together. This is the last problem for today. Mr. Sinofsky used 5/8 of a tank of gas on a trip to visit relatives for the weekend, and another 1/2. Notice that they're giving you word form for a fraction right there of a tank commuting to work the next week. He then took another weekend trip and used a 4th tank of gas. That is going to be really expensive at today's prices. How many tanks of gas did Mr. Sinofsky use altogether? So this one is very special because we have 3 fractions. So on a problem like this, I mean, there are lots of different ways you can go about it. Some students will just take 2 at a time and they'll get that common denominator. I like to say, well, eventually if we're going to combine them all, let's take a look at this method of getting the lowest common denominator. The lowest common denominator. This is the way you do it. You go like this: 8, 2, and 4. These are the numbers that we're counting by. This is all the answer to the times 1. Okay, so if I multiplied by 2, and again, I kind of already know what's going to happen. I mean, I would get 16, but I don't really have to do that. You always kind of want to start with the lower ones. Times 2 would give me 4, and I go, ooh, these have this number in common. And 4 has 8 in common. 4 times 2 is 8. So now I'm kind of getting closer. We can't use 2 as our common denominator because we have to have a number that is the same. So here, times 3, you probably know where I'm going with this, and times 4, I'm going to have 8. So once I have all 3 that have a number in common, you want to use the lowest one possible. Could I keep going and get to 16? Yes. Could I keep going and get to 16? Yes. But I don't want to. Why would I want to use a number that's that big? Anytime you keep going and you use numbers that are this big, it's room for error. So what you want to do is you want to try to turn everything into the lowest possible equivalent that you can. Now, I'm not going to use a fraction model on this one. I'm going to use the numbers. I'm going to change. I'm going to leave this alone because it's already eighths. Oh, there go the lights. See what a big deal it is? The lights went out, so you can pay close attention. Okay, I want to turn halves into eighths. So the question here is, what is my scale factor? The scale factor is on top. That's the number that we're multiplying by to get that common denominator. This is my scale factor for halves. So when you use the scale factor, you will use it on both the top and the bottom. So I will then have 4/8 that is equivalent to a half. So this one has now become 4/8. But I also have to change fourths into eighths. I need a scale factor that will help me get to eighths. What was the scale factor? It was 2. 2 is my scale factor. So then I get 2/8. Now this is my way, and this is how I would choose to do it. The fraction models they're really different, and I think they just kind of confuse kids. So here is the skip counting method, and we will start getting into this actually really soon. It works great for even when you're just adding 2 fractions together, but it's especially helpful for 3. So this is how I would do it. Then I would add up all my numerators together. 5 and 4 is 9, plus 2 is 11. And then you just have to change your 11/8 into a proper mixed number, which is 8/8 for the 1, and then 3 left over. And this would be your tanks of gas. So 1 and 3/8 tanks of gas for his travels. And so I hope this is helpful, and come back again and I will try to help you some more on more videos. We don't have any more problems, so that's it for today. See you on the next video. Bye for now.